Hey everybody, thanks for attending today's webinar. My name is Steve Reed and I'll be your host. Also with us today is Stefano. He's going to be leading us through the live demo after my short little presentation here. And he's also going to help answer some questions for us. So, taking a quick look at the agenda, I'll be going over just a few slides here in PowerPoint, giving you an overview of NetBees. During that time, if you have any questions, you'll notice in the GoToMeeting control panel, there's a little chat window where you can ask questions, and we'll get to those whenever we can. Also, if you have any other questions, you can send them to info@netbees.net. These two parts, the little presentation I have and the live demo by Stefano, will take about 25 to 30 minutes, and then we'll save the last 15 minutes for questions, so we'll be sticking around. Alrighty. So, on average, 20 to 30% of network and application problems are detected by the end user. I can't send emails, Salesforce is down, I can't access Facebook. And that's generally due to a little or a complete lack of visibility by the end user, or of the end user, by the network engineers and IT staff. You guys just don't have the tools to see what's going on for the end users. In a typical scenario, you've got centralized IT that's supporting dozens or even hundreds of locations. And when an issue is reported, it takes a while to find out who and where users are affected. When you start calling users to find out more information, most of the time you get inaccurate feedback, and it's really tough to figure out the exact timeline of events. So traditionally in network monitoring, we've got these two options, SNMP-based and flow data. The problem is these tools, that are available, they aren't providing all of the data that's necessary to support enterprise networks. Now we have a tool that belongs to, you probably have a tool that belongs to one or the other, or probably both of these two classes. First, there's SNMP, necessary to manage a network infrastructure, as they report the status of the network devices like routers, switches, access points, etc. However, they don't provide end-to-end visibility. There's no performance data and nothing from the user perspective. And then, of course, flow data, which is passive packet capture technology, which allows you to better understand how your network pipes are used, who are your top talkers, if a link is oversubscribed, what are the applications that are oversubscribing your network. And this tool also has the ability to do protocol inspection. These are reactive troubleshooting techniques, and they don't provide 24/7 visibility into network performance monitoring data. They don't scale particularly well because they either rely on network caps like inline devices, which are expensive and introduce another point of failure into your network, or they rely on net flow collectors that are sometimes difficult to configure when you have a lot of network locations. Another drawback to these solutions is that they require significant space to store historical data. Large enterprise networks need a solution from a third class of tool that monitors your network with active probes and from each individual network location. And this is what we call distributed network monitoring. Enter NetBees. NetBees is a distributed network monitoring solution that monitors from the end user perspective using small hardware agents, what we call bees. These bees run active tests that measure network availability and performance. The data collected by our bees are reported in real time on the intuitive and browser-based dashboard that really draws a clear picture of the status of the network as seen by the user using color-coded styles. And again, always from the dashboard, the users can access historical data, so it's useful to you as the engineers. And here is where distributed network monitoring comes into play. What if you had a bee at every remote site simulating an end user? And what if this bee could report, 24/7 its experience in terms of the network and applications, and could let you know within seconds when something went wrong. In addition, this bee could store all of your historical data, and you could use that to find out the exact timeline of events, and also know which users and at what locations experienced the problem. We've also added to the family virtual and external bees. And the former allows you to monitor virtual network environments, while the latter enables you to get the perspective of an internet user, making NetBees one of the first hybrid monitoring solutions. So you've got virtual, external, and hardware agents from NetBees. So first of all, you're going to be able to escalate tickets to the right group. NetBees helps you understand the scale of the problem and whether the performance degradation is on the network or the application layer. This in turn reduces troubleshooting time because now the engineers have all of the data necessary to isolate the fault and focus resources on areas of the network that are causing the problem. This can be used to validate configuration changes as well that are applied overnight when there aren't necessarily remote users that can validate it for you. This reduces human-driven outages. NetBees is also a tool that can be used by the network architect for IT budgeting and planning because we have that historical data that allows you to make informed decisions for network improvements. And during the demo, we'll go through and show you where that historical data and information is available. So this is what NetBees is all about. Our monitoring bees are deployed at each remote site. They're pre-configured with DHCP, so installation literally just takes a couple seconds. And within minutes, you can get started with tests that report the status of the network and application of each one site. And as you can see on the right-hand side here, this is what a bee looks like. And in a few minutes, we'll show you how to install one on your network. It's a small, form factor, low-power computer that connects to your network as any other user. It's really just a plug and play. All bees are connected to the NetBees dashboard that act as a central manager, where you can control, update, and view, essentially, again, through that NetBees dashboard. As you'll see in a few minutes, the interface is easy and intuitive to use and capable of managing hundreds of bees. You get access to historical data, you can send alerts, and it really helps you detect and troubleshoot, network and application problems. And this is what we call distributed network monitoring. All right, as I mentioned, that concludes my portion, pretty quick and easy. But before I hand it over to Stefano, I'm just going to answer a quick question here about pricing and the cost. And NetBees is actually a yearly subscription based on the number of bees that you deploy. That price, again, is reflected includes all of the updates that you get automatically, access to the server for historical data, and of course all of our support. If you wanted to ask again about pricing, you can send questions to sales@netbees.net. All right, Stefano's all ready, so he's going to go ahead and walk you through the live demo. He's pretty excited here. All right, Stefano, you're up.
Okay, thank you, Stephen. And hi, everybody. My name is Stefano Gridelli, and I'm co-founder and CEO of NetBees. So here is a quick agenda for this second part of the webinar. During the first part of the demo, I'll provide an overview of the dashboard. And in the second part of the demo, we're going to go through two simple use cases to show you and demonstrate the new features that we're introducing in NetBees with the performance alerts. Very well. So let's start with the overview of the dashboard. So I'm going to switch now and show you that I'm in Chrome. I'm connected to this browser-based dashboard of NetBees that is managing 23 agents, as you can see on the bottom left, the counter. Each agent is represented as a thumbnail, and you can see in real time the status of the tests that each one of these agents are running. So I have a ping, DNS, HTTP, and traceroute tests executed in real time and reported in real time to the dashboard. The status of each test is color-coded, as Stephen was saying earlier, and green means the test is being successful. Red, we have a failure, like in this case, and orange, there is a performance alert, and this is the new feature, right, that we just introduced in NetBees. Performance alert can detect performance degradation like in response time. And if you notice here also we had like two agents that had that flapped basically, and now they're reporting back to the dashboard. If I click on any of the agents, I access what we call agent detailed view, where I can see more information about those tests that each agent is running. So if I click on a specific tile associated to a test, for example, in this case for the ping test or DNS, as you can see, I can review the real-time information, right, for that test, such as in this case for ping round-trip time, for DNS the response time, the query time, and for HTTP the time to retrieve that web page. In traceroute, I can see the number of hops generated during each execution of the traceroute command, in this case to test.netbiz.net. And the historical data of traceroute gives me a breakdown for each run of the traceroute command, right, for that specific traceroute test. In ping, we can also have the historical data, as Stephen was saying, that is beneficial, right, to understand if there are any patterns in the network. And this data can be also collected for days before today. So that is really beneficial if you want to troubleshoot events that happened yesterday or from the day they really you started the test. Okay, the second view or tab is the target view, and a target is a resource that I'm monitoring with the ping, DNS, HTTP, and traceroute test, right, that I push to my agent. And that's actually by creating a target the way I push tests to an agent, right? So in this example, I have a target called Google, right? So I'm monitoring a cloud service application in this case. It could be also a network location, right? I can create also a target that is composed by agents, and this target contains maybe ping and traceroute tests between multiple agents. So I want to, for example, monitor the end-to-end reachability and performance across multiple locations, right? And this could be convenient for voice over IP. I want to show you now how you can create a new target. I click in this big plus sign, right? And now I have a target form. Here is where in the name section, I specify the name of the target, like test target. And I add a description to the target. Okay. Now I can decide how I want to monitor that specific target. Those are the kind of tests that I can use. So let's pick, for example, our website, netbiz.net. Let's create another object. As you notice, we already have it here, but doesn't matter. We can still monitor on another target that resource. So I'm going to use like ping to make sure that users and my locations can reach, from a network perspective, the netbiz.net web server. I will leave the default ICMP interval and timeout. And if I want, I can also specify like the MTU size of the packet if I want to test my path MTU, or I can also set the DON frag bit set. Then to each test, I can also attach what we call an alert detector, right? An alert detector is the condition, the profile that generates those alerts that you see here, right? So the red one is a traditional up-down type of probe or monitoring test, while this is the new kind of alert that we just released with NetBiz, the performance baseline. And in this case, is like a baseline type of alert where if the 1 minute average is greater 2 times than the monthly average, then generate an alert so I can be proactive with the network degradation issues. So we can also attach this alert very well. I add this test to my test templates. Now I'm going to push also a DNS test, right, to netbiz.net. I want to make sure that my users can resolve an IP address given the fully qualified domain name. If I don't specify any specific server, I will use whatever DNS server my agents were configured with, either via DHCP or statically. I leave the default intervals and the default up-down alert detector. Then I click also on the HTTP section. I also want to monitor NetBiz if my users can access the actual web page, right? I maybe configure every 15 seconds to do a test, and leave already this pre-selected HTTP baseline and up-down type of alert detectors. The last one, I can also choose to monitor with traceroute, path availability from the source locations where the agents are installed to the destination, netbiz.net. And I can really simulate a real application packet with a TCP type of traceroute. And in the advanced options, I can also specify the destination port number, which in this case would be port 80. Another thing that we provide is the ability to mark with a DHCP value that traceroute packet. Now that I define the test templates, I can select the agents that I want to monitor that target. So here I have also groups of agents that make it easier to organize, all the agents deployed in my network. I'll pick now 4 random agents, right, just to demonstrate the target. Select the 4 agents, and I can enable or disable SMTP alerts and add any email address that I want to be the recipient of SMTP alerts. As Steve was saying, NetBees can integrate with your network-centric SNMP monitoring solutions via SMTP or actually SNMP by sending real drops. I click Save, and now as you see in real time, a new object is created. The test definition are pushed to the agents, and I'm getting in real time the data from all these agents where I push the test. Okay, moving next, if you notice on the top tab, we have 4 other tabs, 1 per each class of tests that we're running. So what we call these tabs are called the grid views. And here is where you can compare, right, multiple tests. So in the first column, you see the source agents that are running those specific tests. And in the first row, the destination or targets, right, for those ping tests. So this, as I was saying, is the best way where you can compare the performances across different locations to a specific destination, right? You can open multiple real-time graphs and compare this data. So let me show you, for example, that between Greece, in Athens, and Milan, there is some difference in performance, right, to reach Google, as Milan takes a little less than 40 milliseconds, and in Greece, a little more than 60 milliseconds. And this is why performance alerts with baseline and distributed monitoring is really necessary to understand the differences across multiple network locations. The other grid view for the other tests are really similar. You can open multiple real-time graphs and compare the performances. And same for traceroute. You can see the number of hops, right, from each location to a specific destination. The other tab is iPerf, and for those who is not familiar with iPerf, iPerf allows you to generate bandwidth or TCP or UDP traffic between 2 endpoints. In this case, from any agent or an agent, NetBees agent or a bees, and an iPerf server. We'll actually provide a demonstration of iPerf in one of the 2 use cases that we prepare for you. And this is the news, the reports tab, right? Here is where you can review all the performance measurement run by your agents on specific targets. So I can select any target that I have in my target view, like for example Google, select the time window, right? And then click on Get Report. And now what the dashboard is doing is querying the database integrated in the NetBees central server, collecting and processing all the raw test data logged by the agents, and then reporting me for the last day, for example, what is the performance across all these agents to reach Google. So as you can understand, it's a good way to really compare apples with apples, right? How is the performance to a specific destination from multiple locations? And it also allows you to determine which one are the areas, the network locations that underperforms, like in this case, the one in Atlanta, compared to the average, right? But it's also a good tool to enforce SLA with your ISP or cloud service provider, or also to spot problems in the network. Like in this case, there are not high rate of failures, right? But in some events, our customers were able to spot like locations that have a 5 to 10% packet loss, right? And then follow up and be a little more proactive with their monitoring. So in this case, I have the Google target that is running ping, DNS, HTTP, and traceroute tests, and all this data is collected and reported in an SLA report. The last tab is the Alerts Browser tab, and here is where you can review all the alerts logged by the system, right? Because each test can generate alerts, either up-down type of monitoring alert or performance alerts. Say that you want to create a root cause analysis report and you want to specifically dig into a problem with, say, our website, NetBees, or a test application. Here is where you can filter all these alerts to see if you find anything more. And associated to each alert, there is the history button, right, that shows you and points you in the historical data when, during the day and time, that alert was triggered, like in this case, where the spike in response time of the web server. Okay, now that I'm completed with the overview of the dashboard, let's move to the next section, or part 2 of our demo, where we show you some use cases where you can use NetBees specifically for performance alerts. Okay, the first, before we start, I want to tell you a little more about the scenario, the network scenario that we set up for this webinar. So here is the case of a multi-site enterprise network, right, that is located, the headquarters is in Pittsburgh, Pennsylvania, and connected to the headquarters via an MPLS cloud. There are 4 locations in Pennsylvania that have a dedicated and private MPLS circuit, right? And then there are other locations here that are international across in the Western Europe or in the other part of the country that are connected back to the headquarters via the internet across a VPN tunnel. This is really a common practice for many multi-site enterprises, right, like retail or even healthcare or other type of industry. So the network engineer of this enterprise wants to perform a bandwidth capacity assessment from the hub in Pittsburgh, PA, to one of the spoke across the MPLS cloud to Harrisburg, right? And to do so, because he's paying a certain amount of money for his 10 megabit circuit, he wants to make sure that he's getting, right, what he's paying for. So he's using NetBees to generate a bandwidth transfer test between Harrisburg and Pittsburgh. So let's see in the dashboard how we can do this. Just to show you how I organize all my agents, as you see here are all these agents of my test enterprise, right? And I also created some groups, as you can see on the left tab. I have the 4 MPLS PA cloud sites, Harrisburg, Erie, Bedford, and Philly. And then I have the 5 locations with a hub right in Pennsylvania. So what I'm going to do now is a bandwidth test with iPerf. So I'm in the iPerf tab, and here I select the Harrisburg agent as a source, and the destination, the hub agent in Pittsburgh. I then select TCP as bandwidth test, and I let it run for 180 seconds, and that's it. Now the dashboard is pushing the test definition to the 2 agents. The 2 agents actually are pausing the real-time monitoring test, so they don't skew the data, right, associated with those tests, because they're busy generating traffic across those 2 sites. And as you can see from the first results, right, it looks like my ISP is meeting the SLA. So that's good. But let's wait till the end of the iPerf test to really make sure that the average bandwidth is around 10 megabits per second. Another thing that I wanted to point you in the iPerf test is that you can also use it with UDP type of transfer. You can set a specific bandwidth. And you can also use UDP to measure data jitter, packet loss, right, on top of the bandwidth. And the UDP iPerf test can also be used to generate multicast traffic. So if you want to validate that your network can deliver really multicast. And this is something that today is really difficult to do, right, without having a dedicated personnel at a remote location. So as you can see here, the test keeps running. And actually, if we go in the agent view, you can see that those two agents that are running data transfer are now with the test post, right? Because I was saying we don't want to skew the data. But there's something interesting here. As you see, I have two performance alerts, right? Because actually those 4 sites were, I created a target for those 4 sites called internet connectivity. And this target that were pushed to those sites, as you can see here, they are basically measuring the network performance to sites like Google or Salesforce. And as you can see, when I started the iPerf test, the round trip time start increasing. And this is most probably because the common uplink common to those 4 MPLS sites were so used by the bandwidth generated by iPerf that it caused a spike in the round trip time, and my performance baseline alert should be triggered. So with this use case, actually I did it intentionally, but to show you how beneficial could be a performance baseline type of alert, because you can be a little more proactive when, for example, a user is consuming all your bandwidth in your MPLS cloud or any other shared network infrastructure and is affecting other users, right? So meanwhile, let's see if the test is keep running. Yep, we're almost done. And I've also have a slide to illustrate what happened in this case, right? So we had the iPerf test that was consuming the common resource, the uplink to the PA Pittsburgh, and the other real-time test, the ping to the internet performed by the other 3 agents were impacting, of course, in round-trip time. Okay, now that the test is completed, let's see actually if, as you can see now, everything is going back to normal, right? The round-trip time is going back to a standard baseline. And my iPerf test is giving me the result of this bandwidth test. So they were able to transfer an average of 9.38 megabits per second for a total 201 megabytes. So overall, we can say that our ISP is doing it right. Okay, let's move to the second use case scenario. The second use case scenario, I want to show you how you can use also NetBees to monitor a cloud service. Like in this case, we have several business users across multiple sites of my enterprise that they must use this resource. Could be a CRM or maybe a point of sale system, that is hosted on the cloud for retail. And we want to make sure, that they have a good experience, because if they cross, let's say, 0.6 or 0.8 seconds in response time, that is really degrading the productivity of your employees, of your business users. So the network engineer, to be proactive, created a target towards this cloud service with HTTP test, and attached to this HTTP test a performance alert configured with the watermark. So this test, of course, is pushed to different agents deployed all around the enterprise network. So let me show you how I set this up. Let me remove, first of all, this filter to my agent view. Now I have a picture of all the locations of my enterprise. And let me move to the target view to show you the cloud service, the target that I created to monitor this cloud app. As you can see here, I'm monitoring both ping, DNS, HTTP, right? And let's edit this target because I want to show you the alert detectors that I attach to this HTTP test. Okay, so you see here the HTTP in the edit. I added this watermark, and this watermark basically generates an alert when the 1 minute average response time crosses 0.8 seconds. Because above that, the user experience starts really degrading, and it can really affect my user base. So the network engineer wants to be, of course, proactive on this and make sure that he can detect this problem before the users do, right? And then eventually, if it's something that is on the cloud service provider side, he can quickly generate and escalate a ticket. So let's simulate now like an event where there is an oversubscription of this cloud service, where either for a technical problem or there are too many users connected to this web app, really the end user experience start degrading. So what we should see is really an increase, right, in response time. As you can see here, the response time starts increasing. Okay, here even more than 1 second, right? So now, in fact, we can see that this performance alert start kicking in. Like in Baltimore, they are also maybe not able to connect sometime into the resource because it's so oversubscribed. And if you see also in Cyprus now, things start getting not so nice. And actually, against this service, we also attach some external agent, like in Virginia. We also have an external agent that can monitor web apps, so you can triangulate if it's an internal problem or an external problem, right? By having the view from an internet user, you can be sure that it's not just within your enterprise to have the issue. So as you can see now, you can start seeing a pattern, like always more sites start reporting this performance issue. So now the engineer is getting, in a quick way, really more data saying, hey, it's not something that is on the network side at one specific location, because multiple locations connected to the internet in different ways, as you can see here, right, are seeing the same problem. Okay, I think you kind of got the point. We were able to use a performance watermark to enforce SLA with the cloud provider, be proactive, detect this problem before the users, and escalate. Now with this, I concluded my demo, and I'm going to send it back to Steve so he can open the question and answer session. Thank you.
Perfect. Thank you so much, Stefano. That was excellent and very informative. I did have a couple questions come in. The first one was actually, do you have any use cases for retail situations? And yeah, we actually have worked with Goodwill, and kind of one of the critical failure points at a lot of retail locations are the point of sale systems. We've seen a lot of retailers moving to these real-time cloud-based credit card processing systems, and in these cases, connectivity is really, really important. So knowing that you can reach all the servers you need to from every retail location is invaluable. Also like to add really quickly that customers pretty much are expecting to have Wi-Fi wherever they are, and at every retail store, such as restaurants, pharmacies, or cafes, and retailers care more and more about the end user experience that they deliver. And then another quick one about updates. How do we handle updates? Those are automatically pushed right to you guys as the users from the server. So you don't necessarily need to do that on your end. We do that automatically for you. These are some great questions so far, okay? Okay, and this is actually a question for Stefano. Will the device notify you if a trace route path changes from pole to pole? Stefano, I'm going to let you go ahead and take that one.
Yeah, thank you, Steven. This is actually a good question. Yes, we can actually create an alert if the traceroute path changes, but actually not from pole to pole, but we can use a performance alert to detect a change in the number of hops. So let me show you how this can be done. What you see now, I'm going to the NetBees settings panel, and I go in the section where you can define the triggering condition of a specific performance or up-down alert. If I create a new alert, and I can choose a performance watermark, for example, I can include a type of measurement like a traceroute average hop count, and I can say if the average hop count in the last minute or 15 minutes in average is greater than, say, 10 hops, then trigger an alert, right? So it's not exactly maybe a change in a path from pole to pole, but generally your internal routes must be always stable, like 3, 5, 10 hops. They should not change, bottom line. It's not like the internet, right? So what you can do, knowing that number, you can create a performance alert for traceroute, saying if the number of hops exceed, say, 5 hops in the last 1 minute or 15 minutes, send me an alert so I can detect some path changes or route changes that can impact my end users.
Perfect. All right, one sec. Let me go ahead and read another one of these questions here. And also, just so you guys know, you can send any kind of more in-depth questions to info@netbees.net. And the next one we have here for you, Stefano, are tests run in series or parallel on a bee?
So if I well understand this question, bottom line, an agent keeps continuously running tests, right? So generally based on when these tests are received by the central server, right, they will execute it as soon as the server tells the agent, run this test forever, every 5 seconds. So not necessarily run in parallel, but I mean, yeah, they run in parallel, but not exactly in the same kind of second, right? They just keep running over and over continuously.
Gotcha, gotcha. Okay. And the next one, how does a bee find the server to report to?
Another great question. So bees are plug and play. As Steven was saying, you receive a bee, right? It has DHCP, and then it reports back to your instance. So actually, your server IP address or host name, that is the only information that we need when you subscribe to an on-premise NetBees deployment, right? And then all the agents that we send you from then on and that you order are already pre-configured with that information. So bottom line, it's automatically discover your IP address because that is an information that we can agree before the deployment.
All right, next question. Where is the bee located in the network?
So I guess the agents are plugged anywhere you want. So an agent should be always connected in a multi-site enterprise network, not where there are your servers like a network-centric SNMP-based monitoring tools, right? You want your bees plugged all over the places or on all those locations where your users are connected to. So it's an access layer device. It's not an inline device. It's just another workstation in your network that is plugged generally one per building or office, right? And then the central server, that is an OVA most of the times, is installed in your data center, right? So bottom line, the monitoring is done outside in from the user perspective, from the access layer towards whatever destination or target you configure. And then the central server, the data is at your data center within the virtual appliance, that is the central server.
All right, we just have a few more minutes here, so I'm going to try and get these last few questions out. Will the bees run over PoE, of course, power over Ethernet?
the current version of the bees do not support power over Ethernet. They have an external power supply that is shipped to you with the agent. It has pros and cons, so we understand that. A lot of people actually appreciate the fact that should the power over Ethernet be knocked out for some reason, you still have the agent up, right? So again, no, this is not something that we offer right now.
All right. I'm going to go ahead and wrap it up. If there are any last-minute questions, you can send those over to info@netbees.net. I want to thank all of our attendees today. I want to thank Stefano for leading us through that excellent live demo. And again, if you have any questions, feel free to ask. Have a good one, and have a great weekend.